Here is another question. This one is also from the mpumalanga question paper, June. This is question 6. Specifically, it's looking at the Doppler effect. So here they say we have a traffic officer, and this traffic officer is sitting in a police car. This police car was traveling at a constant velocity. So the siren of the police car emit the sound wave, which is equivalent to the word 1500. So this 1500, it is for the word. This is the frequency by the word, by the source. So because this traffic officer was inside the car, that was there was no relative motion between the word, between the traffic officer and also the word, the police car. It means that the V of this police car, the V of the of the police car, it is equal to the F of the word of the traffic, or the traffic office, which is equal to 1500 hertz. And now they say at the detector, there was a detector that is placed on the side of the road. It records the frequency of 1695. So because the frequency now was increasing, the frequency by the listener was increasing. Why it was increasing? Because it is moving toward the word. It is moving toward the source. It's moving toward the word, toward the listener. So when the source is moving toward the listener, there's an increase in the word, in the word, in the frequency. So the police car take 1,5 to reach the word, to reach this detector. So now we have this car which is emitting the sound here, and this is the sound that is emitting. There's now a traffic officer inside this car. So this car emits the sound which is F by the source, which is 1500 hertz, and now it's moving at the what, at the this time of 1,5 seconds. And here we have a detector, and this detector records the frequency, which is what, which is 1695 hertz. We can see now that this detector, V of the detector, it was at stationary, so it was 0. So F of listener, it is what, it is the 0. And they say that the speed at the medium, which is our V now, at the of the medium, the V of the medium, it is what, is 340 what, ms minus 1. And now the V of the source, we don't know it. And now they say that it is increasing. The V by the listener, it is what, it is increasing, which means now the source is moving toward the word, toward the listener. It is moving toward the word, the listener. And now the first question they ask us to come to say what, to name and state the phenomenon described here. So the phenomenon, when there is a source and also the observer, and also there's a relative motion, and there's also change in the frequency, it means we call it the word Doppler effect. Is this what we call Doppler effect? So what do we mean by the Doppler effect? A Doppler effect is the change, in what? Change in the frequency, it is change in the frequency of what? By the listener, by listener. Why the frequency is changing? Because the sound source, because the one that is producing the sound, and also the one that is detecting the sound, which is the listener, the they have different velocity. They're not moving at the same what? At the same velocity. As a what? Relative to the what? Relative to the medium of the sound, which in this case, the same medium of the sound, it is the what? It is the what? It is our air. So there's a change in what? There's a change in the frequency. The frequency that is what? That is heard by the listener. Why there's a change in the frequency of the listener? Why the listener is not hearing 1500? Because the sound source and the listener have a different velocity relative to the medium of the sound propagation. That's why there is a what? There is a different. So 6.2 now, they're asking us to write down the medical instrument that make uses of the Doppler effect. And this medical instrument is our ultrasound. So what is the function of this ultrasound? The ultrasound function is to measure the blood flow speed and also to detect if there's a blockage in the arteries, and also sometimes to monitor the heartbeat of the fetus, or to monitor the function of the heart valves. So that is our what? Our ultrasound. So 6.1, 6.3. They're asking us to calculate the distance between the what? The distance between this Vs, between the source and also the detector. So we know the formula says that the distance, or delta x, which is the distance, equals to V times T. We already have the what? Have the T is already 1,5, but the V, we don't know it. We know only the V of the what? Of the listener. But what is moving out is what is the source. So we need the V of the what? Of the source. Then we can calculate the what? The distance. So from the formula of the Doppler effect, we say that V by listener is equals to V plus or minus VL divided by V plus or minus Vs times Fs. So when the listener now, if the listener is moving toward the source, we say it is what? It is positive. But if the listener is moving away from the source, we say it is what? Is we take negative. But let's move to the Vs now. So if the Vs now, so we say the source now, the source is away, it is what? Is positive. But if the source toward, which is like in this case, it is toward, we take what? We take negative sign. So in this case, the source now, because there was an increase in the velocity, it means that it is moving toward the what? Toward the listener. So which means now we're going to take this one. So now we can take this formula. We say VL, because now here the listener was what? Was not moving, which means now this one was going to be 0. So we're going to take only V. And then we divide it by. So we have V. We take what? Minus, because the source was moving towards the listener. So it's going to be minus Vs. Then we're going to say we'll multiply this by what? By F of S. Here we're going to say now our FL, we already know it, we are given it. Our FL now, it is what? It is what? It's 1695, already given it. So it is what? 1695. V, it is the what? Is the velocity of the what? Is the velocity of the medium, which is what? which is 340. Is 340 divided by the velocity of medium, which is 340, minus Vs, which we do know, times what? Times the f of the what of the source, which was what? 1500. Now we are going to do what? We are going to divide both sides by this 1500. So both sides we are going to do what? We are going to divide both sides by 1500, both sides by 1500, which means this is going to cancel this one. So 1695 divided by 1500 is going to give us sorry, let's change the pen. It's going to give us 1.3 it's going to be 1.13. Then we're going to say is going to be equals to 340 divided by 340 minus Vs. Then we multiply this side by this one. Then we're going to give 1.13. Going to multiply by 340 minus Vs equals to 340. Then we're going to divide both sides by what? By 113. So we're going to divide both sides by 113, which is going to give 140 minus Vs equals to 340 divided by 1.13, which means now we're going to have 340 minus Vs is equals to 300.88, which means now our Vs, we're going to do the math, is going to be 39.12. When you do the math, this one is going to go, that side is going to be 300.88 minus 340 is going to give us what? 39.13, but it's going to be what? To be negative, and divide both sides by this negative, which will give us this answer. Then I will say now delta, or the distance, is equal to what? The v by the source times what? Times time. Then the v by the source now was 89.12 times the time, which was what? 1.5. Then we are moving to the what? To the answer, which is going to give us what? It's going to be 58.1,7 meter. Then we are done with this. Now let's move to another to the next one. Next one say draw a graph of the frequency held by the traffic officer sitting in the police car as it moved toward and away from the what? From the detector. So we're going to write a what? A graph which represents the what? The frequency held by the traffic officer sitting in the police car as it moves toward and away from the what? From the detector. We're going to indicate the frequency held by the traffic officer and also the time taken by the car to reach the what? To reach the detector. So now the frequency here, because this is the frequency of the traffic officer, and also as it is inside the what? It's inside the car, so the frequency do not change. Why the frequency do not change? Because there's no what? There's not relative motion between the source and the observer. So the traffic officer was not moving, was, or in the what? In the car there was no motion, they were moving at the same speed. So there's no change in the what? In the speed. So there's no difference in the velocity between the police, this policeman, and also the what? And also this car. Because there's no relative motion, it means now if there's no relative motion, there's no what? There's no change. So our graph is going to be like this. We're going to have this at the end, which is time, and also the what? The frequency. So the frequency here is going to be what? 1500 as he approach, is going here he approach up to 1.5. Even when it's moving away, the frequency still be the same. It's 1500. It does not what? It does not change. So I think we're done with this one. See you in the next video. Thank you.